Newly discovered carbon may yield clues to ancient Mars. This is by Penn State University. NASA's Curiosity rover landed on Mars August 6, 2012, and since then has roamed Gale crater, taking samples and sending the results back home for researchers to interpret. Analysis of carbon isotopes in sediment samples taken from half a dozen exposed locations, including an exposed cliff, leaves researchers with three plausible explanations for the carbon's origins. It could be from cosmic dust, or ultraviolet degradation of the carbon dioxide, or ultraviolet degradation of biologically produced methane. The researchers note today, January 17, this is the date of the article, in the Proceedings of National Academy of Sciences, that, quote, all three of these scenarios are unconventional, unlike processes common on Earth, end quote. Carbon has two stable isotopes, 12 and 13. By looking at the amounts of each in the substance, researchers can determine specifics about the carbon cycle that occurred, even if it happened a very long time ago. Christopher House, professor of geosciences at Penn State, said, the amounts of carbon-12 and carbon-13 in our solar system are the amounts that existed in the formation of the solar system. Both exist in everything, but because carbon-12 reacts more quickly than carbon-13, looking at the relative amounts of each in samples can reveal the carbon cycle. Curiosity, which led by NASA's Jet Propulsion Laboratory in Southern California, has spent the last 9 years exploring an area of the Gale crater that has exposed layers of ancient rock. The rover drilled into the surface of these layers and recovered samples from buried sedimentary layers. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Curiosity heated the samples in the absence of oxygen to separate any chemicals. Spectrographic analysis of a portion of the reduced carbon produced by the pyrolysis showed a wide range of carbon-12 and carbon-13 amounts, depending on where or when the original sample formed. And some carbon was exceptionally deleted in carbon-13, while other carbon samples were enriched. The samples extremely depleted in carbon-13 are a little like samples from Australia taken from sediment that was 2.7 billion years old, said House, and those samples were caused by biological activity when methane was consumed by ancient microbial mats, but we can't necessarily say that on Mars because it's a planet that may have formed out of different materials and processes than our Earth. To explain the exceptional depleted samples, the researchers suggest 3 possibilities: a cosmic dust cloud, ultraviolet radiation breaking down carbon dioxide, or ultraviolet degradation of biological created methane. And according to House, every couple of 100 million years, the solar system passes through a galactic molecular cloud. It does not deposit a lot of dust, he said. It's hard to see any of these deposition events in the Earth record. To create a layer that Curiosity could sample, the galactic dust would have to first lower the temperature on Mars that still contained water and created glaciers. The dust would have deposited on top of the ice and would then need to remain in place once the glacier melted, leaving behind a layer of dirt that included the carbon. So far, there is limited evidence of past glaciers at Gale crater on Mars. According to the researchers, this explanation is plausible, but it requires additional research. The second possible explanation for lower amounts of carbon-13 is the ultraviolet conversion of carbon dioxide to organic compounds like formaldehyde, of all things. There are papers that predict that UV could cause this type of fractionation. However, as House explains, however, we need more experimental results showing this size fractionation so we can rule it out or in this explanation. The third possible method of producing carbon-13, depleted samples, has a biological basis. On Earth, a stronger carbon-13 depleted signature from paleosurface would indicate past microbes consumed microbially produced methane. Ancient Mars may have had large plumes of methane being released from the subsurface where methane production would have been energetically favorable. Then the released methane would either be consumed by surface microbes or react with ultraviolet light and be deposited directly on the surface. But according to the researchers, there is currently no sedimentary evidence of surface microbes on the past Mars landscape, and so the biological explanation highlighted in the paper relies on ultraviolet light to place the carbon-13 signal into the ground. All three possibilities point to an unusual carbon cycle, unlike anything on Earth today, House said. But we need more data to figure out which one of these is correct explanation. It would be nice if the rover would detect a large methane plume and measure the carbon isotopes from that, but while there are methane plumes, most are small, and no rover has sampled one large enough for isotopes to be measured. House also notes that finding the remains of microbial mats or evidence of glacial deposits could also clear things up a bit. He said, "We're being cautious with our interpretation, which is the best course when studying another world. Curiosity is still collecting and analyzing samples and will be returning to the pediment where it found some of the samples in the study in about a month." House said the research accomplished by long-standing goal for Mars exploration to measure different carbon isotopes, one of the most important geology tools, from sediment on another habitable world, and it does so by looking at 9 years of exploration. Also working on the project from Penn State was Gregory M. Wong, recent doctorate recipient in geosciences. And there's a list here of other participants in the research, NASA Jet Propulsion Laboratory, and various other divisions of Goddard Space Flight Center and others. And NASA supported this project. And this was, as we said, from Penn State. It's on Science Daily. Please leave your comments. Thank you for your support.